Hi students, and welcome to Preliminary Chemistry and the Chemical Earth topic. In this video we're going to have a quick look at writing formulae and equations. Now the most important thing about writing chemical equations is that it takes practice. So this is by no means a crash course or a comprehensive course, but just an introduction at this stage, and we'll do lots of examples during class time. Now, chemical equations are basically just chemical shorthand. We carry out lots of different chemical reactions in chemistry, and so we don't want to be writing them out in full all the time. We want to be able to have a system that simplifies exactly what we mean when we are carrying out our reactions. So one particular type of reaction, which I'm sure you've seen before, and you will see again, is when magnesium is ignited in a Bunsen burner flame. When that happens, the magnesium burns with a very, very bright flame in the presence of oxygen, and it forms a white powdery solid of magnesium oxide afterwards. So what we want to do with our chemical equation is we want to represent this process using symbols and balanced equations. So the first thing we need are the symbols. And for the symbols, we go to the periodic table. Now, as I've told you before, you will always get a periodic table, so it's not important for you to try and memorize all these symbols. You will learn a lot of them as we go along just because you use them so often. But it's not important at this stage for you to try and memorize all of these things. You'll have this tool in front of you. It's very important that you are able to use this tool effectively. So the first thing we do is we write down the symbol for magnesium, which is Mg, the symbol for oxygen, which is O, and then the formula for magnesium oxide is MgO. So this is our starting point. On the left-hand side of the arrow, we have reactants. So whatever it is that's reacting together, this is on the left side. And on the right side, we have our products. So this is what is produced as a result of the chemical reaction. Reactants on the left, products on the right. The next thing we need to do is we need to make sure that if we have got a chemical formula, that we've got it correct. So the first thing we need, and this is going to be something that we're going to have to learn as we go along, is we look at the oxygen. Now oxygen does not exist as a single monatomic element. Oxygen is an unstable element in its atomic form. It likes to gain electrons in order to become stable, in order to form an ion. And if it can't do that, it's going to share. And the sharing can also occur between two oxygen atoms. So the form in which we find oxygen, therefore, is most often O2. If we were to make this molecule, we would see that there are two bonds between them, and there would be 4 unbonded electrons around each of the two oxygen atoms, just to draw the Lewis structure. So when we're writing our equations that involve oxygen as a gas, we need to write it as O2. Then we look in the periodic table to make sure that we've got the formula for the compound correct. When I look for magnesium, I notice that it's in group 2. And that means that it has a valency of +2. Oxygen is in the 6th group or the 16th group, depending on how you're calculating them, but it's 2 to the left of its nearest noble gas, which is neon. And therefore, it forms a -2 ion when it forms a compound. So oxygen is -2. Now, our rule is that we need to make sure that our compounds are electrically neutral, no overall charge, and the +2 and the -2 will cancel each other out. So this is actually the formula for magnesium oxide. So we then update our formula because we've got now the stable form and the balanced formula for our compound. So this is our compound here, which we're producing from 2 elements. So this would be an example of a synthesis reaction. And they're now in the form that we want them to be in. So the next thing we need to do is balance the equation. So what we understand, one of the laws of chemistry, is the law of conservation of mass. So matter can't be created or destroyed in these particular types of reactions. We just rearrange the atoms. Now what you'll notice is that when we do a count, we have 1 magnesium on the reactant side and 2 oxygens, and we have 1 magnesium but only 1 oxygen on the product side. When we're putting our numbers into balance, and this is why this must occur after we've got all our formulas correct, because if we say, well, the easiest way to do this is to put a 2 there, then this actually becomes electrically charged, and it will be therefore the wrong formula. So the only way we can deal with this is to actually put a 2 at the front. When we put a 2 at the front, it multiplies everything together. So it means 2 magnesiums as well as 2 oxygens. So that means we've got another step. We've got to then put a 2 in front of the magnesium at the front on the reactant side. Now we have doubled our number of magnesiums. We haven't changed this one, so it stays at 2. But now we've doubled both of these, so a 2 there, and we still have that 2 there. Of course, that, as I said, is not what we want to do. So that means that our final equation here is 2Mg plus O2 gives 2MgO. Now there is still one more step that we can include when we are writing our final equations, and that's to include what we call the subscripts. Now the subscripts are what shows the state, usually at room temperature, for each of the substances involved. You remember that the magnesium is a strip of magnesium, so it's a solid. Oxygen is just taken straight out of the atmosphere, the air in the room, so it's a gas. And the powdery substance that's left behind of magnesium oxide is also a solid. So the addition of these subscripts, once the equation is balanced, tells us everything we need to know about this particular reaction. That magnesium is a solid, required 2 lots of magnesium for each 1 oxygen molecule in order to produce 2 lots of magnesium oxide. Now this is something that we'll look at in a little bit more detail in later videos. Thanks for watching.